In this video, we're going to look at some vector geometry. That's using vectors to help us solve some geometrical problems. First of all, we've got a parallelogram here, and we need to find the vectors for these given vectors here. So first of all, for PR, we go up and then along. So PR is equal to PQ plus QR, which is equal to A plus B. For QS, the next part, QS, we've got two ways we could do this. We're going to go down here and then across there. QS, so QS is equal to QP plus PS. Now QP is the opposite way to PQ, so that's minus A, and PS is just B, so minus A plus B. For part C, we're asked to find QX, where X is the midpoint. Now it's important we know that X is the midpoint of QS, because if X is the midpoint, that means that QX is equal to a half of QS, because it's the midpoint. But we know QS from the one above, so it's a half of minus A plus B, which is equal to minus a half A plus a half B. In part D, we're asked for PX, and to get to PX, we want to go, first of all, up PQ, and then down QX. So PX is equal to PQ plus QX. Well, PQ is just A, plus QX, we've just worked out, is minus a half A plus a half B, and when we simplify that, we get a half A plus a half B. We're now told that Y is on the line RS, such that 2RY equals SY. So 2 of these equals this bit. As you can see, I've got the fractions written in here. That splits them into a third and 2/3 of the whole length RS. So to find RY, we want a third of RS. So RY is equal to a third of RS. But RS is the same as QP, so this is minus a third of A. QY is QR and then RY, so that's QR plus RY, and that is equal to, well, QR is just B, and RY we've just worked out is minus a third A. And finally, for this question, XY, we can do that in several ways, but the easiest way is probably to go XQ, QR, RY. So that is equal to XQ plus, well then it's from Q to Y, Q to Y, which we just worked out in the last part. So XQ we worked out above, that was here, we worked out QX, so it's the other way round to that one. So it's going to be a half A minus a half b, because we have to make everything negative because it's in the opposite direction. And then onto that we're going to add qy, which is what we just worked out, which is b minus a third a. And when we simplify that, we get a sixth a plus a half b. So that's this first question. Now let's have a look at a second question. So in this question, we're told that AB is equal to R. So this here is R. And AD is equal to S. So this whole length here is equal to S. AY to YD is 1 to 2. So we have this length to this length is 1 to 2. That means YD is double AY. So up here we have a third S, and down here we have 2/3 S from Y to D. From dx to xb, that's also 1 to 2, so that means that this is half of this one. So we're asked to show that yx, this line here, is parallel to AC. That's this length here. So yx is parallel to AC. So let's have a look at these. Part 1, we have AC is equal to, or AC, we have to go along AB plus BC, which is equal to R plus S. Now yx, we have to work out yx. Well, yx is equal to yd plus dx. yd plus dx. yd, we said was 2/3 S. And dx, well, dx is 1/3 of db. Plus 1/3 of db. But db is minus s plus r. So now we can put that in. So it's 2/3 s plus 1/3 of, and that was minus s plus r. And when we simplify that, we get 1/3 r plus 1/3 s, which is 1/3 of r plus s. Now, why does this show that they're parallel? Well, we can see that AC and yx are scalar multiples of each other. That is, we can multiply 1/3 by rs to get yx. And that's how we know that they're parallel. So to finish off, we have AC and yx are scalar multiples. And that tells us that they are parallel. In part 2, what is the ratio of yx to AC? Or the ratio of yx to AC? Well, yx is 1/3 the length of AC. So it is 1 to 3.